everyone. It's a pleasure to have you here for yet another exciting edition of Stories Behind Products. I am thrilled to share the story of Speaksee, a design-savvy product that improves the lives of people with hearing impairment. I'm Oya Demirbilek, a professor of industrial design at UNSW, and I am delighted to welcome you all from the beautiful country where I live. I pay my respects to the traditional custodians of this unceded land, the Bidjigal people of the Eora Nation, and acknowledge their elders both past and present. So this evening, our presenter is Joshua Flowers, an alum of Industrial Design Honors at UNSW. It is great to have you here, Joshua.
Thank you very much for having me. It's an absolute pleasure to be here and an honor to speak in front of you all tonight.
So a bit about Joshua. He is an accomplished and innovative professional with a strong background in design and communication. So he received a Bachelor of Arts in Communications, Media Arts and Production from UTS, and a Bachelor of Industrial Design Honors from UNSW. And Joshua is currently the Chief Commercial Officer at Paper Moose. And 6 years ago, he founded Circle Studio in Sydney, designing, manufacturing, and selling high-performance computer cases, prioritizing functionality and exceptional design. And Joshua's global experience includes working as a lead industrial designer at Speaksee in Amsterdam and as an industrial designer at Wahl&Ross APS in Copenhagen. And previously, Joshua worked part-time at Street Furniture Australia on new product development and as a design researcher at UNSW. And Joshua has many prestigious design awards, including a Good Design Australia Gold Award for Circle Pro, a Good Design Australia Communication Design Award, and a European Product Design Award for Design for Society. He was also a Mercedes Benz Design Award finalist and a Young Australian Design Innovation Award nominee. And you can ask your questions to Joshua via the chat function. And now it's time for him to take the stage. So over to you, Joshua. I stop sharing.
Awesome. Thank you so much, Oya, for those kind words. I'll just share my presentation. All right. Chat if you can't see that. All right. So I'm here to talk to you about Speaksee. My name is Josh Flowers, as Oya said. I guess as a little kind of background on me, I'd like to just run you through on a quick couple other projects I've worked on in the past. So a project I've worked on in the past was Circle Pro, which was a computer case which won a Good Design Gold Award. Think kind of Apple computers, but for modular Windows computers. It was a project that I designed, prototyped, assembled, with my good friend Anuj, who's also an ex-UNSW alumni. We marketed, sold them, shipped them hundreds of units all around the world. We got reviewed by big tech YouTubers. We got incredible rave reviews of the product. And then one day I discontinued it and stopped selling it. Maybe that's the story for another day. Another product I worked on was the flower chair, which I designed in collaboration with Street Furniture Australia. This actually started as a student project at UNSW. This was the first model I made of it. It was a sense of place competition that I won, and I actually had the privilege of being able to prototype and then manufacture that product with Street Furniture Australia, something I'm really grateful for. Another project I worked on more recently was the development of a company called Wow Mountain. We make completely 3D printed products out of corn starch bioplastic, PLA, as you all know. In this case, 3D printed flowers, which I design and manufacture with my partner, Missy. It's kind of like a collab project. Our latest project is a set of 3D printed bronze rings with detachable 3D printed tops, which attach with a single quarter turn. All that to kind of illustrate the fact that I love designing products and I love bringing them to market specifically. I guess you could call me a serial entrepreneur. I love coming up with ideas and then finding a way to make them into businesses. So within that context, Speaksee has been a massive challenge. Probably of all of those products that I've just shown you, Speaksee has been by far the most challenging project I have ever worked on. And it is a project that is still in play 7 years after I started it at UNSW. So welcome to my TED Talk, and I'd like to kind of run you through some of the biggest lessons that I have learned so far in the making of this project. So very top level, first of all, for those who don't know what it is a kit of wireless microphones, which you wear. I have a kit right here. And the idea is you attach it to your clothing or you hang it around your neck, and it turns what you say into text in real time. Now, the real killer feature of this is that you can have multiple microphones, so you can use it for group conversations or group transcription. Now, why would you need that? I'll get to that. So it started, as I mentioned, as a UNSW student project. I graduated from UNSW in the 2015 class, a pretty good class if you ask me. And this was me in the final grads presentation, looking a little bit younger there. The problem I was trying to solve was that of hearing loss, and specifically late adult onset hearing loss. Specifically the hearing loss of this guy here, my granddad, my dear granddad. In his 70s, he started experiencing hearing loss, and like anyone else with hearing loss, he got a pair of hearing aids, which worked very well for a long period of time, let's say a decade. But it continued to get worse and worse to the point where they were no longer effective, and he wasn't able to communicate with his friends or family anymore. Anyone who knows anything about hearing loss, when someone reaches that level, it's very easy to start developing dementia because your brain is just no longer active. And so it's very important to be able to continue to communicate with people. Also at that age, you're not really in a position to be learning sign language. So there had to be a better way, right? And I guess the way that we found was using Apple Notes or equivalent and using the transcription button. And we just hit transcribe and we get it to type out what we were saying in real time. And that was the best solution we had. And we thought, well, this would be great as long as the transcription continued for more than 30 seconds, which it didn't. So that was kind of the core of the idea. It was, how can we take the idea of this transcription system and make it more user-friendly and make it into a product? So UNSW led us through a fantastic series of design and research exercises, including an experience it session where we were encouraged to experience what it was like as a deaf person with artificially muffled sound. I ran a co-design exercise with my granddad to kind of ask him what he would like from a solution of this kind. I did many user interviews and discovered lots of insights and brought them together into a research report, which suggested a couple of different design solutions. One of them being this, the idea of hearing microphones. You can see in this design, it was much thinner than what it came out to be in reality. And also it had 5 microphones. So it was definitely shooting for the moon with this concept, but all in all, the concept was there even from the very first design research document. This was the humble first prototype. So from cardboard prototypes, which are beautiful, by the way, to a finished product is truly something to experience. There was an especially great UNSW activity, I remember, which was called Future Fiction. The idea was to imagine how the product would function and look like. What would be the design philosophy and essence of the product? For example, would it be invisible? Would it be out of sight, out of mind? Technology gets in the way of natural human interaction, therefore it should be invisible. And this is how a lot of hearing products on the market currently operate, because people are ashamed to have hearing loss, and there's a lot of stigma. So people would usually prefer it to be invisible. I decided to go with friendly universality in a bid to destigmatize the condition. So by going with lighthearted playfulness and not taking the condition too seriously, that was the goal. So if there are any questions which come up in regards to the design style, that's why. Very kind of specific strategy to destigmatize stigma. So from there, it was just a matter of doing Illustrator mock-ups, coming up with concepts, went through hundreds, if not thousands of iterations of what the microphone should actually look like. These were just early form studies. And the student projects basically came together after many, many, many revisions. This is what I delivered at the final student exhibition. And all in all, it's remarkably, I mean, it's not the same, but it's similar. It's similar to the finished product. At the same time, I also delivered a functional prototype with one of my friends who's a fantastic coder. We developed this app on a Raspberry Pi using a USB microphone plugged into the side there, and it was able to produce live transcriptions. The trick was it could only use one microphone at a time though, and getting multiple microphones to work turned out to be a very difficult challenge. At that time, I was also lucky enough to win a Good Design Innovation Award. That's not the right icon there, but an innovation award for that product. So my kind of one of the first lessons there that I can pull from looking back, finding a real problem to solve is incredibly valuable because it gives your project inbuilt momentum. So I just want to thank UNSW and all the fantastic lecturers who are on this call for the great guidance back in the day. Which brings us to part two, the kind of the startup phase and the prototyping of the real product. So I actually got a job off the back of the graduation exhibition. And I got to work at a design firm from also an ex-alumni of UNSW, Drew Ross Kelly and Wahl&Ross, all-round genius design and engineer and a fantastic guy. It was fantastic to work with him. At that time, I got an email out of the blue from Jari Hazelbach, who was the co-founder of Speaksee. He said that he'd found my work through the Good Design Award and also my portfolio website, which is a reason to keep a portfolio website, saying that he had come up with a similar idea to what I proposed and that could we work together to make it into a product. So we met up. As I said, I was in Denmark at the time. They were in the Netherlands, very close countries. We just, after a short flight, hung out, and after that meeting decided that we would go into business together. I would license the concept to them essentially in exchange for being a co-founder and having equity in the business. And we went all in basically in making the product work. Yari's parents were both deaf. That's one of his main inspirations for wanting to start the company. So literally, you know, I think it was our second meeting. I mean, we weren't beating around the bush. We started to prototype. Yeah, we had working prototypes with us at all times. We were non-stop in CAD and using 3D printers to create prototypes. These were the earliest prototypes we had. We had an off-the-shelf microphone component. That's that kind of blue circular part attached to a more custom PCB board. Just using off-the-shelf electronics items. This was the first prototype of the dock. And you can see how we've just colored in texture around the colored rings. I guess a lesson here for anyone who's new to developing products, prototypes don't need to look good. It's just about technical validation at this stage. But I think from any seasoned product designer, I think you'll agree with me that these are beautiful. Working prototypes are beautiful. Here's Jari wearing one of the early prototypes. And it was around this time that we launched an Indiegogo, and we raised over 270,000 Australian dollars. And once that closed, we were like, oh, okay, this is serious now. Better make this a reality. So, by the way, I forgot to mention that I wasn't even working on this full time. I actually, I work full time in a business that I co-founded, a creative agency called Paper Moose. And I've been working on this project. Oh, sorry. At the time I was working at Wahl&Ross. But we realized that we had to go to Shenzhen to prototype this product. So we did. And this is me and Marcel, the CTO of Speaksee, working on some of those early prototypes. We spent a solid month there together, just getting the next version of the prototype mocked up. For anyone who doesn't know about Shenzhen, it is an amazing city. It is like Blade Runner made real. It's quite a modern city. I think it's only 40 years old. Before that, it was a sleepy fishing village because of a kind of a special economic zone that China put in place. It was able to proliferate essentially in a couple of decades. But I mean, Apple makes all of their products there just because it is the hub of technology. They have gigantic buildings with multiple floors, and each floor are just filled with hundreds of stalls. And in each of those stalls, they sell anything and everything to do with electronics and product design and development. So it is an absolute haven for prototyping. You know, you can buy a lot of this stuff on, say, eBay or AliExpress, but being able to be there on the floor, being able to buy a pack of pogo pins to, you know, assemble into a prototype that same day, that's something else. I also just wanted to show this video of the Shenzhen Light Show. I'll just let you watch it because it's so amazing. It's kind of like Vivid, right? It's kind of like Vivid, except it's there all the time. This is their central train station, by the way. And it's not projections. They're LEDs on the actual buildings, and they're all connected in one AV system. And you know, would anyone like to guess how often they run that? Is it once a year like Vivid? I'm just going to answer it. Once a night. They do that every evening. So that's Shenzhen, amazing place. Not as fancy was my desk, which you can see is a complete mess, but this is where true innovation happens. You'll notice all the bottled water because we weren't allowed to drink tap water there either. This was one of the Shenzhen prototypes. You can see it was sort of super rectangular. It had this strange magnet clasp concept where the clasps kind of hung on the side of the dock. They just sort of sat there, and it had a really dorky power switch, and I don't know, it was something. I was just experimenting. It also had at one point a strange reset switch, and it had programming ports. You can see I was experimenting with the way the microphones looked and the power buttons worked, and yeah, I didn't quite know how it was going to work. I guess that's a really important point, is that you need room to explore in the design process. I wasn't super concerned with failing at this stage, so we failed a lot. We made a lot of prototypes as well. And of course, being in Shenzhen, we could just get PCBs made daily. So we were constantly getting new parts made so we could test them. Here was an early prototype where we were conveying the color of the microphone through the LED on the actual device, because each microphone will be represented in the app by a colored chat bubble. And we thought, well, why don't we just present it with a blue LED? The problem is that we wanted to show more than just RGB. And this LED could show those three colors really, really well, but finer gradations of those colors, it just did a very bad job. And you'll notice in the final product, we use colored pucks. And there's a whole series of them in the pack. I'll get to that later. At the same time, in the Netherlands, another team was working on the app, which is, you know, a huge part of the user experience as well. So a lot of development went into that. You can see here some of the dock prototypes coming into fruition. We went through hundreds of revisions of the actual dock PCB. Yeah, it's just interesting looking back on it now how much it changed. And yeah, we 3D printed hundreds of prototypes. Here's one of the display models. I guess a lesson for me, and again for any kind of new designers out there, when designing for injection molded plastics, never design thin-walled rectangular objects. Compound curves are your friend for rigidity and strength, and I'll just show you what I mean there. if you design something flat and square or rectangular, it warps. It warps really badly. Look at the lines on the side of this. It just wasn't holding any shape at all. So I'm sure the senior designers out there are looking at me and shaking their heads, but you have to make these mistakes sometime. So although they were really squidgy and they didn't work very well, we rolled with them anyway, and because that's what we had. And we started to send the prototypes back to the Netherlands where user testing was being done. And then I started work on the next revision, and I was trying to implement some of those curves, those compound curves into the design. I was trying to work out a way to get the color back into the design. I was experimenting with this big sliding switch on the front, and then also changing up the way we connected it to clothing. You can see here it was a spring steel clip. So that's kind of to give you a bit of scale. And here was another concept where we were going back to that colored ring like we had on the original prototype. And here again was a completely different concept where it was kind of an early version of the color puck. This would kind of pop out, so you could replace it with a different color. But throughout the failing, at least we were failing in the right direction, and we were starting to converge onto a design which started to make sense. You can see the evolution of the flat magnet to a magnet with a lanyard strap all the way through to the spring steel clip. Let's just talk about the clip, because often on a design project, there will be one or two elements that really stand out as the biggest challenges. And on this one, it was the clip. And if I could go back and redo parts of the project, I would definitely revisit this. Not because the clip isn't good. I think it's a really good solution what we came to, but maybe it shouldn't have had a clip at all. The reason for that is the first concept was a magnet. The second concept, I thought it should have a lanyard, kind of like an old iPod shuffle, because it keeps the microphone at the correct distance from your mouth for perfect audio transcription and easy to wear. But at some point we changed direction and decided that a clip would be nice to have. And so here you can see the spring steel clip version, and then close to final version with the plastic clip. You see, the challenge here was making a clip that was functional, that could fit on a pocket or another piece of thicker clothing, but also be super thin. It's like 3 millimeters. We didn't want to make the dock much fatter because it was already starting to get bulkier than we would have liked. But we have the physical limitations of requiring a battery inside the dock down here. So we were working with this tiny, tiny space. So here you can see some experiments with spring steel. We tried different thicknesses. We tried prototyping them up in different metals. We tried integrating the spring steel on the inside of the case. You can see it bends inside here. But the problem with that was that it was getting very close to the PCB. And if you got too close to that, it would short it out. So we decided to try and keep the clip on the outside of the body, meaning you could slide it in through these teeth here. In the end, I think we came up with something that didn't seem intuitive at first, but was very effective. And that was making this hook and attaching it to the back of the microphone first, such that it kind of hangs down here. The reason we attached it and we ultrasonically welded it was because you can't actually injection mold that kind of shape. It has all these kind of underhangs and these tiny details. So it was actually this very difficult to design object, but it ended up working quite well. And the reason we've got this little anchor is so that you can show you here. So there's the anchor there. And the idea is you take the clip and it fits on the anchor, and then you slide up and it clicks in place, and then it's locked in. Now, the reason we wanted to have the clip so that you could remove it is in case someone decided to bend it really far and then snap it. And you can't have an expensive electronics product like this. The clip breaks, the whole thing's useless. So you had to build in some kind of redundancy feature in there. So I'm really proud that we managed to solve that problem. But that was after weeks of sleepless nights and constant problem solving. So at this point, we were starting to kind of converge in on a final design. And one of the things that an industrial designer has to deliver at this stage is a CMF, a complete document showing what the product looks like, the colors specified down to the Pantone codes, the finish requirements, the plastic polymer requirements, all of these things. I learned a lot on this specifically. In particular, how to specify finishes. Like I thought you just said glossy. I just like a glossy, please. And they're like, what kind of glossy? What grade of glossy? This was my first time working with a VDI chipset. Swatch, thank you. I remembered it. Quite expensive to purchase, but this kind of swatch, you can feel all the different textures of the plastic that you want molded into your product. It's a fantastic reference. Another thing industrial designers have to deliver at this point, technical drawings and the exploded charts. This is the official exploded diagram of, I think, close to the final design. So you can see there are a lot of parts in there. And, I'm kind of glossing over this, but this was years of work at this point, and developing a product like this is an insane amount of work, requiring a team of diverse skills. Especially when you're a startup. In some cases, we had less than one of any of these people at one time, because maybe we'd bring someone on a project basis for a couple of weeks here or there. And we ended up having to do multiple versions of these jobs ourselves. And at this point, I was no longer in Denmark. I was back in Sydney. I was working full-time in another job. So whenever I was working on this project, it had to be part-time, like in the evenings and weekends. When it comes to manufacturing and managing a project of this scale, I'm sure everyone loves a good project plan. Problem with plans, of course, is that they never got a plan. And we initially thought we were going to go into mass production in August 2020. How hopeful we were. But we did do one thing right, and we actually engaged a rather top tier contract manufacturer in China. And I'd never actually worked with a large contract manufacturer like this. And immediately they were sending me emails and presentations with notes, and they would help me out with the design. It was fantastic. It's like it was like going from a team of one designer to a team of 20. Suddenly there were more resources. And they would help me out find, small mistakes like this, which is just, I'd made a small mistake in the CAD, to helping out with structural simulation, the type of polymer we'd require on the clips, such that when you're using 8 newtons of force on the clip, it doesn't snap. To drop testing simulation on the case. And just extremely helpful mechanical engineering tips from simulation results. In this case, there was a snap lock, which when fully extended would snap in the wrong way. So, in this case, we just needed to rotate a couple of faces 45 degrees. Working with a contract manufacturer of this caliber was an incredible experience, especially realizing that we as designers are not mechanical engineers. Often the roles do overlap at some points, and some people are better at others at each side of those skills, but I'm not a mechanical engineer first. But, I did learn a lot of, important plastic injection molding design strategies from UNSW, and I tried my best to incorporate them to the design. But an engineer comes back and says, actually, you need to change this boss from, this to this. It's such a huge help. So we were starting to converge on a final design, ready for mass manufacture. We had all of our final parts, rapid prototypes. We had a lot of the technical drawings done. And we had all of our 3D step files prepared. I would just say a wrap-up lesson there is DFM, design for manufacturing, is super complex and time-consuming, especially for a detailed product like this. And if you're a small team or a startup, teaming up or working with a good contract manufacturer, highly recommend it. So it was at this phase in the project where things started to get very intense. Once you start getting close to that, the first phases of production, you can't leave anything to chance. So we would have weekly manufacturing meetings with the contract manufacturer, and we would just go through, all these tiny details in incredible precision. And it was grueling. It went on for months and months. Yeah. I'd never experienced anything quite like that before. It got to the point where, we had to specify, down to each individual step, how to assemble it in the factory. There were lots of gaskets and double-sided tape and making sure the battery doesn't short the circuit board. So there were just so many little details until we got to tooling. And again, this is something I wouldn't have been able to do. I wouldn't have been able to place where the injection pin locations go on the tooling. I wouldn't have been able to tell you where or exactly how the sliders or lifting parting lines would have worked. So this was a very exciting time. And for anyone who loves design and loves tooling, I hope you agree with me, this is very cool. Seeing the tooling was a very exciting moment. Here's the tooling for the power buttons, for the lanyard clip, and the back clip. Notice the back clip is super shiny. That's because that particular part has a glossy finish. And there's the tooling for the bottom or the top part of the dock. So now I'm just going to show you some videos of the injection molding process. So that's the injection molding for the dock. Any polymer nerds out there, we're using a PC ABS mix because it needs to be both impact resistant and chemically resistant and rigid. And this is the pad printing process. So this is putting the logo on the dock. You can see why manufacturers like the pad printing process, because it's as simple as making the tool which the part sits on and then just hitting the go button, and it's super quick and super easy. And we made lots and lots of jigs in the process of making this product. This one in particular for testing the dock PCB. And I haven't even begun to go into things like the user experience and the user guide. I worked. My partner designed this, Missy. She's a graphic designer. She did an awesome job on the user guide, and I worked on the packaging. I'm not a packaging designer, but in a startup, you got to do what you got to do. So this was the packaging. There you go, printed in white. They initially digitally printed it, and we wanted a silk screening, which gives you that really nice solid white print. And of course, the carry case. I had to do concepts for the carry case I have on here. That's kind of like a Bose headphones case, I guess. The idea is when you're paying good money for a product like this, by the way, about 650 euros plus a yearly recurring fee. But the idea is you want to carry around in a nice case that protects it. And this was a whole design project just by itself, specifying materials, the inner tray that would hold not only the device itself securely, but chargers, all the accessories, a 4G device if you wanted to take it mobile, which was a use case for some of our customers. And at this time, I started to receive some of the plastic parts from the design testing stage. after tooling starts, some people think, oh, well, you know, I'm nearing the end of the project, but it's kind of only just the beginning, because at this point you have to start setting up the testing facilities. Again, for a complex electronic product like this, a lot of testing is required. You've got to get you know, CE certification, and you've got to be testing EMF and all that kind of stuff. So that there was a lot that went in, which the CTO, Marcel, he basically lived in China for a couple of years to ensure that all of this stuff went off smoothly. Hats off to him. They did tons of testing. This is battery testing. This is thermal testing in an oven. That says -25, so that's a freezer actually. And you know, checking the PCBs. This was Marcel's office for a while, so you can see he was just in hardcore testing mode for a long time. And this was one of our audio test dummies. So December 2020, 3 years later after actually starting the project, we reached DVT1, which means design validation testing. And this is when I started to receive the first physical units, which weren't working completely, but nearly complete. And at this stage in industrial design, it's our job to go through and create a report on how it's functioning. In this case, I would take pictures, I would make notes. For instance, in this case, we created a cardboard cutout which would hold all the power adapters in place, and you know, for whatever reason it wasn't holding in place properly, so I called that out, and then we designed up a solution to make sure that it was more neat, that kind of thing. And just one interesting note is that without specifying it, everything from a factory comes in a plastic bag. Everything from the packaging itself to everything inside the packaging. You see, it's a babushka doll of bags. That for me was a big learning. And I know it might seem like a small or a petty thing, but single-use plastics proliferate throughout the supply chain. And you know, it's our responsibility as designers to ensure that we need to exclude them, and we should be at every stage. So it was quite a lot of work just to get them to exclude. They actually fought me on a couple of items. They were like, "Oh, well, we need the plastic bag to protect the box," and I was like, "Why?" And they were like, "Because you know, you might get a scratch on the logo." So we ended up going with this, which is instead of an entire plastic bag, it's just a sticker which protects the logo. Even that, you know, I wasn't super happy with, but you know, that's the compromise we came to. And then this phase, I started getting color chips and color chip samples, and I'd never done this before, but basically you receive color chip samples in these sunproof bags so that they don't fade. And then you have to okay the colors, and then they show you 3 grades of the colors: the lower bounds, the mid bounds, the upper bounds of the manufacturing process, and whether you're okay with those thresholds. And I was. And this was the solution we had for the extra color pucks. Like I said, the idea was to extend this product. So you buy one and then you buy another, and you can have 3, 6, 9 people all partaking in a conversation. And for that to work, we would need to ship the same colors by default on the original unit, but you could always switch out the colors for new ones we had in the pack. Of course, specifying the cloudy plastics was challenging as well. How much percentage of gray we wanted in those clear light pipes that we had made. Deciding, you know, the darkness of the laser marking on the unit. And then, of course, the whole lanyard clip thing, which was sort of a reverse engineer of the lanyard clip late into the project. This was when we decided that we didn't want a lanyard, and then we decided we wanted the lanyard back. So then I had to reverse engineer this into the design very late stage of the project. So it was quite challenging to make that work. Just a little lesson. I know this sounds like a silly lesson, but never assume the location of a logo or a text on a product is obvious, i.e. just center it. Always provide detailed measurements to avoid mistakes. And the only reason I bring that up is because it literally cost us months. It cost us months of troubleshooting, getting a power button icon centered in a circle. Yeah. And then of course, the little tiny details that you'd never think about, like the dimensions of the box and how you stack it in the other boxes and how many boxes you can fit in a bigger box. And then how many of those boxes you can fit on a pallet. I'm just going to show you a quick video of the assembly line. I didn't take this video, so apologies for the shakiness of it. And this was also recorded over Zoom, but I'll walk you through some of the steps. Here you can see glue being inserted for the magnets. You can see the magnets being attached with this ingenious method, by the way, where you actually have a magnets of the opposite underneath in the jig. So you don't have to think about the positioning the magnet. Genius. I didn't come up with that idea. Here you have filters being put on the microphone holes. We have parts being heat welded in place. We have the microphone sponges being placed. They were little sponges which had to go on top of the magnets such that they didn't short the PCB. PCB is being attached to the dock casing, the battery being installed, that then being pressed with an exact amount of pressure so that they could ensure that there weren't any failures of the battery. The units being scanned, closed up, being put into testing chambers where they then have to go through a battery of tests. There was also an audio testing chamber, specifically because this is an audio processing product. We'd have to test the microphones are working. This is the anchor on the back of the microphone being attached. Here's more heat staking. All of these jigs, totally custom. Microphone stickers, adhesive on the pogo pins, contact sticker, separating the battery from the PCB, assembling the microphone with thread cutting screws, closing up the microphone unit. This is doing a similar process to the dock for the magnets for the lanyard clips. Lots of lanyard clips ready to go. That's how the lanyard clip kind of magnetically attaches, checking that, you know, all the clips are working. So you can see the manufacturing line was a whole thing. And the idea is that we're set up in mass manufacturing for thousands of units. Part 4, coming up close to the end, but basically product and market. You've made the product, now what? This is ironically and interestingly the part where I actually have very little to do with the project because I'm living and working in Sydney, Australia, and the company's in the Netherlands. My kind of deal with this project is I would design and help manufacture the product, and I wouldn't be so involved with the business on this because I have other stuff I'm doing. But yeah, there's a whole company, 10 plus people making Speaksee a reality in the Netherlands right now. This was the first production run arriving at their office. You can see them trying to stack them into their office elevator. The product is out there. It's been tested with users. It's also been sold business to business in a couple of countries in Europe, and the users who are using it, it is changing and helping their lives. Currently 250 plus customers. They've divided their users into elders and work professionals. So they have a kind of clear business strategy. Again, I'm not super involved in the business strategy level of this product, however. In terms of testing, Speaksee is outperforming other apps in terms of voice to noise ratio, i.e. how good is it at filtering out background noise. That was one of the key features of this product. And in English, Speaksee makes much less errors compared to almost all other apps, including Google Live Transcribe, which was an app which actually came out halfway through the development of our product. And it's probably the gold standard at the moment in terms of live transcription apps. It's very good. The problem is it can't be used for more than one speaker. As soon as more than one person starts speaking, it completely breaks down. But even against that, even against Google's flagship product, our product is fantastic. And Yari, the CEO of Speaksee, has just been doing an incredible job of raising hundreds of thousands of dollars in funding, winning all sorts of awards. I actually can't keep up with them, but my hat's off to him. And as you can imagine, with a product like this, which is completely custom design, hardware, firmware, completely custom firmware, software, you need a technical roadmap. You don't just launch it and it's finished. There are tons of things that need to be worked on and improved. And they have an incredible roadmap. Not even to mention the app, which has been something in development for years. One of the latest features they just released is the ability to change the color of the microphone. So you can change the pucks on the front, then change the color of it in the app. And of course, the reviews in from early users are really positive. I love my Speaksee. I'm just going to call out one. One day my carer was trying to use it when she was in the kitchen and I was in the living room, and I could understand what she was saying. Wow, what does that feel like after 25 years of silence? I can't put it into words. I'm so emotional just writing about how Speaksee changed my life. From the bottom of my heart, thank you all to the Speaksee team. So yeah, I'm not super involved in this part of the project, and my hat just completely goes off to that whole team who are making that happen. So a lesson there is creating and launching a product to market is not the end of that product. It is the beginning, and commercializing, marketing, and operationalizing a successful business model around a product is perhaps more challenging than building the product itself. And what about this guy? Well, I got to show him working prototypes that were very close to the finished working prototype. I didn't get to show him the finished version. He died early this year, unfortunately. But I hope that the product that he inspired will go on to help many granddads and grandmas like him in the future. So that's the end. That's the end, but also the beginning. And I just like to recap some of those lessons. A product like this takes 5+ years to develop, not 6 months. So prepare for a marathon, not a sprint. Only run a Kickstarter Indiegogo if you and your backers are fully committed to going that distance. Initially, my business partners thought we could do the launch of the product in 6 months. I tried to push back on that. Finding a real problem to solve is incredibly valuable because it gives your project inbuilt momentum. You will need to go through multiple major design revisions before landing on a design that is viable for mass production. Prototypes are meant to be ugly, and failing often is part of the process. Factor this in at the start. Learn about the design for manufacturing phases, EVT, DVT, PVT, T0, T1. They will help you stay focused on the needs of each phase. When designing for plastics, never design thin-walled rectilinear objects. Learn from my mistakes. Compound curves are your friends for rigidity, strength, and stability. DFM, design for manufacturing is extremely complex. It takes a long time. Working with a good contract manufacturer, especially if you're a small team, is crucial for success, or if you have someone who's a trained mechanical engineer. Manufacturers love to use plastic bags by default. You have to specify that you want to exclude them. Never assume the location of logos or text are obvious. Always provide detailed measurements. And final thought, but kind of just tip of the iceberg for a whole discussion really, is hardware is hard. It is so difficult. Even if you pull off a project of this complexity to perfection, there's no guarantee the product will succeed in market. And in many ways, finishing a hardware product like this is just the beginning. So from this, a cardboard prototype, to this, a finished product, yeah, 7 years in the making. I hope that was interesting. I'll be taking questions. I guess I had to keep this brief, and I wasn't even able to cover half of the interesting discussion points. So happy to chat about it if anyone is keen.
Such a great story. Joshua. It's full of
Thanks.
lessons showing the power of good and thorough design research, a solid design process, entrepreneurship, experimentation, iterations, collaboration, and dealing with an insane number of details and complexity, and perseverance, of course, and such a great product that impacts lives positively. So great, thank you. So I'll start reading the questions. Please ask your questions via the chat and I can read them to Joshua. One question came from Sebastian Adams, and he says, some familiar pain points on production I've experienced there, Joshua. Thanks for sharing. You may save someone a lot of pain.
Oh, I hope so.
And he says, can I ask, what was the volume of your first full production run post-pilot?
It's split into 4 stages. So I've given advice to learn all the design phase names, and I haven't followed my own advice. But before mass production, there were a couple of shorter production runs, and I think we were talking I think the first one was 300 units, and then the second one was 800 units, and then mass production 1 was something like 3,000 units, and then mass production 2 is something like 6,000 units.
Thank you. So the next question is from Oliver Kratzer, and he says, fantastic, congratulations for getting a product to market. How much product/market fit research did you do upfront?
Yeah, good question. I obviously, as a student project, I researched the general deaf market at large. I went and talked to audiologists, and I went to Cochlear, for instance, and talked to them about their research. And the late deaf adult was my particular focus, with kind of an extension focus on people who are interested in transcribing group conversations, like business meeting minutes. So that was kind of a preliminary thought on what the market would be. I thought we were going to go direct business to consumer. It turns out the business model that has worked best for this product has actually been business to business. So Speaksee sells to large companies, usually as part of, for instance, like the NDIS in Australia, the equivalent of that in the Netherlands. One Australian company that they've actually been working with is Australia Post. Australia Post has bought a tranche of units. So, sorry, in answer to the question, I did a lot of research, but even if you do lots of research, you're not going to know what works until you test the market.
Right. I have one question, and it's this is such a project where you learn so many things, and you've done other projects as well, other products that are on the market. So what are the main things that you used in the new products that you did afterwards? What are the main learnings that saved you hardship?
I'd say one of the biggest learnings of this that I haven't really talked about yet is the idea of minimum viable product, and being able to test a functional product with users in a way that means you don't have to get to mass production before you do that. Like, obviously we did a lot of testing. Obviously we did a lot of user testing with this product, but the kind of fidelity required to get a proper user test with this product is unusually high. We needed a system with multiple streams of audio, with a custom firmware hub that then talks to your phone, that then talks to the internet. It was very difficult for us to get minimum viable product testing on this product. So I would say the most important thing for me is just being able to test concepts as early and often as possible with as little upfront investment.
Thank you. So there's another question from Amy Fang. She says, hi, Joshua, best presentation ever. Thank you so much for sharing this story. I want to ask, I recall you saying that you worked at a different full-time job. How did you manage your time to run this personal project on the side? Would love to hear about any experience or advice on this.
With great difficulty. So I would finish my work, And so I'd clock off at my job and I wouldn't leave my desk, and then I would start working on this, and I would stay in the office until, I don't know, 11 p.m. Not every night, but when we're coming up to a deadline, or they needed an updated CAD file, or there were a lot of stressful moments. I would call it a lumpy process, because sometimes there'll be nothing for like a week or 2 weeks while they were working stuff out, and then they were like, Josh, we need the latest design, and I was like, okay, let's get it going. And I'd spend like 2 weeks of hell and late nights. It's not for everyone.
Definitely not. The next question is from Christina Zlomislic, and she says, one of the most memorable student projects for me. I'm thrilled to see where you've got to. Well done, Josh. Wish you continued success, Christina.
Thank you very much.
It's not a question. And there's also, I think it's another comment from Miles. And Miles says, more a comment than a question. I remember this project so well at when you started this UNSW. It's remarkable how similar the concept and vision is to the final design after all the many challenging steps involved in the development process, especially since the computing hardware and text-to-voice tech has changed so much in the last 7 years. Yes, there's also that technology keeps changing.
Yes. It actually is a small miracle that this isn't completely obsolete yet.
Yes, and I have another follow-up question, and then I think we'll finish there. Is AI.
Yeah.
Are you going to include AI in this?
So yeah, the company is actually no, I probably can't talk about that.
Okay.
But yeah, AI has been on our radar and my radar for this design for years. But before my life as a designer, I actually worked as an audio engineer, and I do actually have some insight into audio and the limitations of AI. AI will be great. I predict AI will be great at speaker differentiation, being able to, with one microphone, split multiple people up and determine who's speaking, but it's still not great at being able to make good audio out of bad audio. Yes, you can filter noise out. Yes, you can increase the noise to floor ratio, but if a microphone is, sitting over here in a noisy restaurant, and you're never going to be able to get a good audio source from me if I'm talking in a noisy restaurant. So just the bare physics of audio are super important. And in my previous life as an audio engineer, I knew that we had to get the microphone source as close to your mouth as possible. So that was kind of the core of the idea. And remarkably, through the testing, you've seen the results of that still holds true. So at least that part of the project is still modern and up to date, and I don't think we'll be replaced by AI for at least the next 6 months.
Thank you. And there's another question. I think it's the last question. Frederick Sundstrom is asking. She says, first, great presentation and amazing project. Thanks for sharing. Joshua, how long did the machine learning process take? Machine learning,
yeah. So for those who don't know, that there's a technology in the product where, so there are multiple strategies. One, where you have multiple microphones worn by the users, which separates the audio. And two, we're using machine learning as a noise cancellation technique. So each microphone is able to intelligently cancel out the noise from the other microphones all in real time. Very difficult thing to do, by the way. So I wasn't actually involved in the technical team who implemented the machine learning on that particular problem, but yeah, that particular one took at least 6 months, if not longer.
Okay, so I think we are going to finish here. Thank you, Joshua, for this excellent presentation, for sharing your story. It was a pleasure to have you here today. Also, I want to express my gratitude to everyone who attended this evening, making it even more unforgettable for us. And I need to share my slide. Thank you. Yes, I'll just share my slide. Oops. Yeah, I need you to unshare.
Oh.
I think I managed to do it. Yep, fantastic. There we go. Yes, so finally, we have our next edition, of course, happening very soon. Our next edition of Stories Behind Products will take place on October 16th, and Amy Lidham another outstanding alum of UNSW Industrial Design Honors Program, will be our next presenter with the story of Cadence Suction Irrigator, a surgical device that plays a vital role in maintaining a clear surgical site during laparoscopic surgery that also enhances procedural flow. So stay tuned for the invitation to this event, and we look forward to seeing you again for the following stories behind products. Stay safe and well until then. Goodbye, and thanks again, Joshua. It was fantastic.
Thank you very much for having me. Thank you, everyone.